we have about 30 people at MIT, and from multiple disciplines. So we got city planners, architects, designers, working together with mathematicians and physicists that focus more on data analysis, working together with engineers. Almost every team that we put together to explore a project involves people from multiple disciplines. It's key, the multidisciplinarity here, because if you think about, if you want to study this kind of new cyber-physical city, you need to understand cities, you need to understand people, you need to understand the new types of technologies, the old technologies, in order to address it in a meaningful way. As most research happens, especially in a growing field like ours, which is studying the intersection between digital technologies, the built environment, and people. So what's the new interface between us and the places we live in, mediated via distributed technologies? As it is a growing field, it's an exploration, so actually identifying the question is part of the research. We identify what a place needs and what we can contribute, what are the challenges and opportunities of a place. But we always start with an umbrella brief. And for Cape Town, we're looking at transport. So the partnership is with the City Hall, but championed by Councillor Brett Heron and Melissa Whitehead. Our key goal is to rethink some of these old systems and ask how are they impacted by the introduction of new technologies into the built environment. How can we understand what drives people to get on public transport? How can we better link taxis, minibuses, rail, buses, I would add private cars, bicycles? How can we make the connection between more smooth, using digitization of systems, using cell phone infrastructures, using software, using visualizations? Now think about all of this in the context of the digitization of networks, digitization of ourselves in the sense that we carry quite strong computers in our pockets, right? So in South Africa, in Cape Town specifically, there's great cell phone penetration. It crosses socioeconomic boundaries. So that provides us with unique data to understand something about flows in the city. Flip it on its head. If you take from every cell phone tower in the city information about how many phones are connected to it, you don't need to know who the phones are or what people are. It's basically data about the towers. You know where the towers are. Suddenly you have a proxy for the intensity or density of people in a certain place. Very powerful, in real time. Sample size is huge. The pre-existing condition here is something exciting if we can do even a minute improvement in it. Some of the legacy of the previous regime. What it left, the imprint it left on the built environment, the fact that places are separated from each other, that it's not so easy for certain communities to connect with others. We can somehow help bridging that. That's very, very exciting. And the city has made a commitment to do as much as it can to overcome it. So some transport systems don't connect to places. Sometimes there's a physical barrier. Take the cell network, for example, as an overarching blanket that crosses those boundaries indistinguishably. Right? So you can understand, for example, how different parts of the city connect to the center. Where do people come from? How do people move? It's all aggregated, anonymous, extremely powerful data set as a way of understanding what could be, what needs to be serviced better. We want to ask, how can you actually think about managing the demand given the advent of digital technologies, whether it is via interaction with people through cell phones or other type of data interfaces. It could be on the transport system itself, like embedding different types of technology within the transport system, in the stations, on the vehicles themselves, at home, internet, people's cell phone, smartphone, SMS, apps. What it can create in terms of economics, in terms of driving equity, right, with regard to the disparity between, say, income levels throughout the population. The plan is to issue a class at MIT with students that would actually study the place, rephrase them, make them suitably relevant to the actual subject matter that we explore. How does a digitization of physical environments allow us to improve livability in cities? And this will be with a focus on mobility in transport systems. And then drilling more deeply into those questions, they will come here in March for a site visit. So the idea is to come up with a set of 4, 5, 6 blue sky ideas that push the boundary. Then we go and think together with a city. They find one of them particularly exciting or two of them. Then we have full-time graduate researchers or postdocs in the lab actually going deeper into them, revisiting the brief, detailing it further based on what's been proposed, based on the feedback from the city, and then starting to do some let's call it more detailed engineering. So if there's software to be developed or hardware, starting to actually prototype. And then in the consecutive years, we can keep on going deep into one or two concepts, or every once in a while, revisit and write a new brief. Revisit the topic of exploration, writing a new brief and re-embarking on a completely new direction. This is our commitment to constantly push the boundaries of knowledge.